All right, everybody, welcome back to the All In Talk stage. Well, we're going from service to salary. See, I'm good at alliteration. This is why I have the job. This talk focuses on optimizing the validation process and the participation rate of salary surveys. Believe it or not, this resulted in a surprisingly complicated AI solution that went beyond the initial goals for the initiative. So we've got two awesome speakers, a partner at Normandin Beaudry, Étienne Boucher, and the Director of Product Management at IVADO Labs, François Marcoux. Gentlemen, hand please.
All right. François and I are very excited to present you the AI model we have been working on over the past few months. A model aimed at optimizing the way we manage salary surveys at Normandin Beaudry. To begin, a brief word about who we are. Normandin Beaudry is a Canadian consulting firm with nearly 400 employees. We advise several hundred clients each year in the design of their total reward offering, which includes retirement and savings plans, employee benefits, and compensation practices, so that they can offer their employees a distinctive, attractive, and competitive total reward package. To achieve this, one of the key tools we use is an extensive database of salary surveys. Each year, we gather employee salary data from several hundred organizations via an Excel-based questionnaire. This database allows our experts to accurately estimate the market value of a job, to understand market trends, and to base recommendation on reliable data. I'll let François explain what IVADO Labs does.
Merci, Étienne. IVADO Labs, we are a builder of custom AI solutions. So we work with medium, large Canadian enterprises to help them with their decision-making, optimize processes. As of today, we have around 60 plus AI solutions in production in Canada, but also the world. Ultimately, those help support billions of revenues being generated every year. And if you want to learn more about what we do, we have our booth right behind you on the corner there.
About 5 years ago, I received a call from a long-standing client who works for a major high-tech company. She told me that she recently lost 5 of her top tech engineers for smaller companies due to significant differences in pay. After some research and a few calls within our network, we understood that the AI wave that arrived in Canada and that the war for talent and for money had arrived. The big fish were about to eat the small fish, and from our specialist perspective, it was a really interesting period. Our university and AI communities, such as MILA here in Montreal and the Vector Institute in Toronto, are currently in the process of developing enough talent to meet the needs of Canadian organizations. At the moment, however, much like what we saw in the video game industry a couple of years ago, there's an imbalance between the supply of talent and demand. And this is expected to persist for a few more years before leveling out. At this time, I attended an executive program at MIT, which made us aware that these emerging technologies will transform our ways of working, and that we, at Normandin Beaudry, would benefit from exploring how to leverage them in our firm. Our focus now would be on automating the job matching process in our salary surveys, the area with the most promise of potential impact. Up to that point, we had spent 1,000 hours annually on validating jobs matchings to ensure the quality of our data. Automating this process will provide us with a huge gain in efficiency and also lay the groundwork to scale or to increase the number of participating organizations without increasing the time we dedicated to validation. While using AI in matching an organization jobs to our survey benchmark jobs might have seemed simple at first glance, it ultimately took us 4 years to complete. At first, we work on a random forest-based model with one of our in-house PhD employees, a data scientist, but the model underachieved for new jobs. After a few weeks of trials, seeing no added value, our employees prefer to continue validating matches manually, just as they had done in the past. At that time, we're talking just about 3 years ago, LLM models were not well known or used. We made several attempts with external providers to improve the model, but these efforts were largely unsuccessful. However, about a year ago, we had the opportunity to partner with IVADO Labs, with whom we had already had a business relationship. What convinced our group, our shareholders, to invest with them was based on just a few very important criteria. One, the depth and the expertise of the team. Two, the structure type of collaboration proposed, which François will explain in more detail shortly. Three, the fact that IVADO Labs were tech agnostic and willing to work within our own tech environment. And finally, the flexibility they show in their contractual agreement, which includes a commitment not to use the model for commercial purposes, no ongoing cost after the delivery, and an engagement not to work with a list of stated competitors.
Merci, Étienne. So first of all, we'll take you a bit through the process that we went through to ultimately deploy the solution. So we like to use a very agile approach at IVADO Labs. We typically work with really cutting-edge technologies and models, so that kind of gives us the flexibility of adjusting to interim results, making sure that ultimately the solution that we launch is the best one available at that specific point in time. And so the project with Normandin Beaudry was really no exception to that. So the way we do things practically is we start with a solution blueprint. Here the idea is really to make sure that from a risk standpoint, the solution is feasible, the data is there, the business case makes sense, right? In this case, we were using with LLMs, and keep in mind this was a bit over a year ago, so they were a bit more novel. So we wanted to make sure that there was actually an LLM that we could use to, a sufficient level of performance that we wanted in this situation. So that's the blueprint. Then if that kind of passes and we're satisfied with the outcome of that, then we go into a POC, proof of concept. Here the idea is to baseline the model performance and make sure that the business case stands up to that, and that based on those initial results, we think we can achieve something meaningful for the client. If that passes, we move to the MVP, and this is where we start putting the solution in the hands of a lot more users, and basically making sure that we can get their feedback, we can iterate on their feedback, basically make the solution better and better. And then if that works out, then this is when we start working on putting this in production, scaling up, right? So in Normandin Beaudry's case, we put the solution, or we finished the MVP in the summer, so a few months ago. And we've been tweaking a few things, making sure that everything is ready for Normandin Beaudry to use it in their upcoming Rémun survey cycle. One key thing as well here is that we always aim to work as one team with the customer. As Étienne mentioned, right, we want to make sure that they're able to maintain a solution, support it by themselves, maybe even build upon it, right? So really aiming to work as one team throughout all those stages is something we strive for. Again, to make sure that from a knowledge transfer standpoint, everything is easier in the long term. So that's from a process standpoint. Now, if we look at the solution more specifically, the way it works in very simple terms is we take into account a job title from one of the clients. Let's say in this case, we have a Directeur, digital channel and strategy, right? So we want to take this title and map it to the most likely benchmark jobs in the Normandin Beaudry benchmark, right? So in this case, we'd want things like Directeur marketing, Directeur spécialité de communication, and things like that, right? So how do we achieve this? So in this case, we fine-tuned a language model specifically to that task. That is to say that we did not use a API or a GPT or a Gemini. We actually took a open source model and fine-tuned it specifically for that task. The main reason being that this was a specific enough task that we found that this actually gave us the best results in this case, rather than using kind of a general purpose solution. And so once we have that fine-tuned model, the way it works is, again, relatively simple. We prompt it using the job title and then some contextual information, such as the industry, for example, and other terms. And then we get different outputs, and then we use those outputs to kind of measure a relative probability of the different benchmark job titles, which we then use to create a top selection of job titles. This is in very simple terms. As you can imagine, things get a bit more complicated once you get to actually doing this, right? So a couple of things to point out. First of all, ALMs tend to give unpredictable results. We call those hallucinations very often. This was no exception to this. So one of the ways we mitigate this is that we actually use multiple language models, each fine-tuned to specific dimensions of Normandin Beaudry's cartography. So as you can imagine, the list of benchmark jobs that Normandin Beaudry maintains isn't just a straight-up list of different jobs, right? There's some structure to it. There's job families, job subfamilies, job divisions, each having their own logic. So what we actually did is we actually trained specific models to each of those dimensions, or some of those dimensions, to ultimately narrow down the job titles that we think are relevant and make things a bit more predictable and controllable. And this obviously being very critical in this case because this is meant to be client-facing, right? This is not an internal tool. Secondly, as you can also imagine, jobs are largely defined by their salary structure, and language models are notoriously bad at dealing with numbers. And so our solution actually isn't just composed of multiple language models. It's actually multiple language models stitched with more classical ML techniques that we use to predict the salary structure of the incumbent job titles. And then we combine those outputs to come up with a prediction that we think makes sense, given the nature of the job, its industry, et cetera, but also its quantitative salary structure. And then lastly, also one key thing of the Raymond survey, right, and one of the main value proposition element of Normandin Beaudry is that their survey is also meant to stay up to date to market trends. So what that means is that every year you have new job titles appearing in that cartography, right? So if you think about a couple of years ago, data scientists weren't a thing. Now they are, right? So we have to adapt to this. And so the way we do this is we actually we use a different LLM model to create synthetic data for the new job titles. And then we use this to also train the LLM that we fine-tuned. And we found that that gave us a good enough baseline to manage those new job titles. But obviously, because of the uncertainty, we also have some UI components to allow users to make changes to it and make sure that whatever synthetic data we're generating makes sense given the business context of those titles. And so the main takeaway, right, I think everyone should have out of this is that, yes, general purpose solutions are getting better, but if you want to kind of get to that last stretch of performance, you kind of need to think about those elements, those things that make your problem specific. Where just using a Gemini or a GPT right off the bat might not be sufficient. So if you put all of this together, what we're looking at now is multiple language models stitched together, each tackling a specific dimension of the Raymond cartography. Then to train those, we use historical survey data from Normandin Beaudry, dating back to 10 plus years, that we combine with synthetic data to train those models. Then we also have, as I said earlier, a machine learning model that handles the salary portion of the equation. And then other things that I didn't talk about, for example, Normandin Beaudry has clients that have been with them for multiple years, right? So if, for example, we have one client telling us that a specific job title is a specific thing, we can keep this into account, right? We don't need to make a prediction for those. We know that that mapping has been done. So we also have simpler statistical models that handle those job titles. And then on top of that, we also have a few elements to detect outliers and make this information available in the solution so that we can display this in the UI and maybe help guide the user to specific titles that we think maybe are more prone to errors than the others, for example. So overall, this is what you're looking at, and then what you get out of that is a pretty good prediction of the job that you should map a job title to. Etienne, back to you.
All right. What you see on the screen is the UX of the final solution now available. Unlike what was done in the past, organizations that participate in our survey will no longer have to match their jobs to those of our surveys. They will simply have to extract all relevant data from jobs and salaries from their HR system and then submit their questionnaire. The solution will display a window that we see that identify jobs that are perfectly matched to those of our survey jobs and those requiring further validation. It will also highlight jobs that should be excluded because they are not represented in our benchmark job surveys, those in red that we see, like a zookeeper, for example. This solution will be used extensively by our clients and our consultants during the next survey cycle starting in January. And if we've piqued your curiosity, you can swing by our booth on the right back corner over there for a quick demo. At the same time, you might just discover a bit more about the market value of your own job. Finally, because we operate within a very niche market segment, the solution we develop with IVADO Labs is not going to revolutionize the healthcare industry, nor will it make major advances in our fight against climate change. But we are convinced that, while niche, our solution is about to transform the practices within our industry, saving hundreds of hours annually for higher value consulting. It will enhance our clients' experience and engagement, giving us a competitive edge, and it will also support our firm's social commitment by promoting more equitable pay in society. Our collaboration with IVADO Labs has yielded great results. One, it has empowered our experts through hands-on work on AI technology. But these partnerships also had enabled us to discover additional AI applications, like our own new internal NB assistant that we see on the screen, our own ChatGPT, which supports our consultant in their daily tasks, streamlines our RFP responses, and assists in generating compelling proposals. So we are very proud of this transformative advancement, and they are giving us a lot to look forward to. Thank you.
Merci.